Hello student, welcome to the physics classes, philosophy of physics. As per every day at 11, please do like, share and make the subscription of my channel and press the bell icon to get the regular updates. Thank you very much. Today we will do the classes projectile of motion. So first of all we have to learn what is projectile. Previously, what you have learned? Motion in a straight line. We have did it. So, after motion in a straight line, scientists have said that another motion is there also. This is a rectilinear motion. So, another will be motion that is projectile motion. So, what? This is projectile motion. If we pelt a stone, throw a stone, so it will go like this way. If you throw from here, so it will go by this way, whatever maybe this way also. So these are the various cases of projectile motion. Now we have to learn it. What is actually projectile motion? So projectile motion, we can make it. This projectile motion is a combination of two things. What are the two things? Another first thing is horizontal motion. Another one is vertical motion. Vertical motion. So these are the two things, a combination in a projectile motion. So this is the projectile picture of a projectile motion. Now what you have to learn, when the case is like this, if the x and y axis, and if we throw a ball like this, throw a ball like this. So from this, if it is the origin O, this is V plus V naught, so V naught x, and this is V naught y, x direction, y direction. These are the two parts we made it. So from very beginning, what we have seen, like this. This is V naught x, V naught y, and this is arc theta. In this angle it goes like so. After this, at a certain point, it will go here. Similarly, for the vector formula, the vector composition will be this. And this is the scenario. Similar, it will seem like this, but now here. But here, the Vy, this scenario, the Vx will like this, but Vy will be 0, is equal to 0. You have to keep in mind, at the peak, top peak, here, when the motion will go like this to downtrodden, so up to here, it will be 0. This is should be keep in mind. So these are the scenario. Again, it will come like this. Vy, Vx. So this will go like this up to here. So these are the scenario while in a projectile motion, and the object which through this projectile motion goes, it's called the trajectory path. It is called the trajectory path. Trajectory path. It's called the trajectory path. Now, after this, these are the basic scenario. We have learned this. The formulas. Now we'll go to the formulas. What are the formulas? Formulas are like this. So previously, when the body was in a rectilinear motion or motion in a plane, what we have learned? S is equal to ut plus half ft square. We have learned this. V is equal to u plus ft, or you can say v naught, whatever may be vx. Now, from here, in this picture, particularly this picture, when I draw like this way, this is the origin. So this is x0, this is x0, this is let it x up to this. Similarly, if this is y0, this is y. So these are the scenario. So we have to from x0 to x. So it will y also like this. From y0 it will go like this, and y, that is pictures. So the formula is this. If we divide the composition in the sine and cos theta, always keep in mind all the horizontal motion defined by cos theta. Similarly, all the vertical motion consists of sin theta. It is a thumb rule. Whenever you do the numericals, or you have to give the answer proper, if any questions is there, give the logic. Keep in mind, horizontal means cos, vertical means sine. So these are the two parts. Now, what we are just keeping it rubbing. Now, if we throw a stone, so if it is in x0, and if it goes to x, once a distance, this is the distance the stone will cover or the particle will cover. So this, in the rectilinear motion, what we did, like s1, s2 or s0 to st. Similarly, here also the formulas will come like this way, from x, final position of the particle or final position of the stone, like this. So the primary, when the ball or the particle in the primary position means x0, x0. So similarly, what will get? X minus x0, s is equal to ut plus half t square, what we did previously. So various equations we did so far. So here, if this is s, the difference between this s, so what will get? So this is a v naught at the very primary, the velocity, initial velocity, let it v naught, initial velocity, final velocity in the x, it will be vx, nothing else. So it will be v naught. So it will be initial velocity, as well as if this angle, keep it in mind, let it theta, or theta initial, theta 0, theta naught. So it will be what we did previously, vt. So here cos is there, cos theta. So cos theta will be what? Cos theta naught. V, we got v, and t, so along with t. So we got this. can write like this, so V naught cos theta, like this way also. So these are the scenario for the horizontal, as I told you previously, horizontal, all the horizontal. This is for the horizontal. If we omit this, cos theta, cos 90 degree means, cos 0 means 1, cos 90 means, tell me, is 0, so it will be 1. So we can write V naught T. So these are for the horizontal. Now similarly we'll do the vertical part. This is the horizontal part, so we'll now do the vertical part. So what we're doing here? So similarly vertical part will be this, as I told you previously, y minus y0 V naught. Similarly V naught will come here. We'll do the sine theta 0, as because of initial value we taken to 0. So this will be for the vertical part, this will for the horizontal, and this is for the vertical part, vertical part. So in the place of this V0 T, we can write the similar way, like this, like this. Now the question is this, we have to learn. So in the cases horizontal we got this, but in the cases for the vertical, here in the horizontal cases, always keep in mind, always acceleration will be 0. In the horizontal cases, when it goes in horizontal cases, acceleration will be 0. But in the vertical cases, I am writing it later on, as I didn't write it here. So in the vertical cases, so we did V naught sine theta t. As I told you previously, it is a negative acceleration. So here the acceleration will be minus g. Acceleration will be minus g. Negative acceleration, because of the gravity. So the gravitational force, so automatically it comes as a minus g. So what we can write, minus half g t square, this one, g t square. So these are the scenario we are getting. Now these are the two scenarios. Try to keep in mind, in the cases of the horizontal, that is acceleration means, here acceleration is equal to 0, or the 0, but here it is a minus, here the g is minus. These are the 2 points you have to keep in mind very proper way. So now we'll do here. So after this, the velocity part, this is the distance traversed through the projectile motion, the trajectory path, the distance covered. By these two formulae it is used for the distance covered. Always keep in mind, the horizontal, the acceleration here is 0, here the acceleration is minus g. Keep it in mind. Now what we did, now v, velocity. Now velocity will be, as because of it goes, the vertical acceleration and the horizontal part is 0, so velocity will be, we can write what will be like this. So velocity in the y direction, obviously velocity in the y direction. So velocity in the y direction will keep v0 sine theta, as because of we started with theta naught. So these are the thing. So velocity will be minus g t, as I told you. This acceleration will be negative. Keep it in mind, as this is the vertical direction, this is the vertical direction. So vertical directions will give you a negative acceleration. Always keep in mind, these are the very vital, very vital. This part, this part, this part. Automatically, when if you get this Vy, automatically you will get what? Vy what? Vy, another will get this along with this Vy square. What will get? V square will be square plus 2fs here in the plane, in the motion in a plane. Now here we will get the same thing. What we will get here? Same like this. V naught 0 sine theta 0. Here minus, automatically it will become minus, as because of it previously known 2g s y. So y minus y0, whatever may be, we have written it y minus y0. Y minus y0. These are the formulas. 1, 2, 3. If we combine this, limit 4, and this is 5. These are the 5 formulas. As similar like the motion in a plane, we got the same thing here also. Now, after this, the trajectory. What will be the trajectory? Now I am wiping it out. As I from very beginning I am telling you, projectile motion is a combination of horizontal and vertical motion both. Projectile motion is a combination of horizontal and vertical motion. Is a combination of horizontal and vertical. What we learned so far, the scenario is this: the vertical motion always gets the negative acceleration, the horizontal motion got the zero acceleration. So these are the two combinations from this concept, from sine and cos. So trajectory will be what we have learned in the trigonometry: sine by cos. Sine by cos, we have learned sine by cos theta. So in the case of trajectory, what? Why the distance travel? This the trajectory. Trajectory path. What? Why? So from sine theta by cos theta we have learned tan theta. So we will use the tan theta formulation. So you use the tan theta formulation. What will get? Tan theta as a very prime state. So it will be what? Tan theta in this case will be tan. If we make this like this, x or y, whatever may be, it will automatically sine by cos will come tan theta. Now, as I told you, it is a negative part. The acceleration is a negative one here. As because of the acceleration is negative here, so we'll place a negative. This is the handy formula. I am making it very easy way, so you can understand it. Where to place and how to place the equation, the formula. Okay. In a very lucid manner, just understand this one, you will can answer all the part. So we'll place a minus here as because of it is negative. So the acceleration what? The acceleration is g negative. This g along with this it will be what? X. So x square. Now what we have did this. So 2fx, this will, now this formula will be 2. Similarly, what we previously learned, cos theta 0, we have did this x. So these are the formula square. So cos theta, sorry, not x, this is the formulation. So this will applicable to the trajectory path. So we can apply, we can do the numericals applications applying this formula. So this how, and my question is how this will come. This will come this is as because of we are dividing all the compositions of the vectors as well as the motion into sine and cos. That's why this tan came in the equations. So keep it in mind, the trajectory, when you do the numericals on the trajectory, you have to apply this. If you get all the compositions and if you get all the elements from this, so keep it in mind. You will get a y, you will get a x. So these are the basic concept of the projectile motion. So after this, what we learn, this a little bit of numericals. Maybe I don't know whether it is possible today or tomorrow, but the trajectory path, when any cases, I'm giving an example, a fire, a rocket, a stone, the projectile path is this. Always keep it in mind. This is the projectile and this path is called the trajectory. So in each every point you will get this composition here, this will negative this. So these are the scenario you will get up to here. Up to here. So from starting, we'll make a starting. So these are the scenario. This is the basic formulation for the projectile motion as well as the trajectory path. Now the range, what will get the range, horizontal range, what will be the range? Now this, what will be the range? I'm keeping it marking on. What will be the range? After this, range. Okay, so will be the range. So what will be the range? In the cases of fire or a rocket or a stone, there should be a range. The distance traversed, the maximum distance traversed is called the range. So this, what will be this range? What will this range? The basic scenario, you will get the range will be what? The range will be the similar thing as because of we did in the rectilinear motion. So this will range is the similar thing. So you need this V naught square by G. This is the basic formula, and as because of the sine part is there also, sine gives you the vertical motion, so it will give the sine 2 theta. So these are the formula of range. And how far the stone or the rocket will go. So this formula is applicable. So what we have learned, horizontal motion, vertical motion, and their formulas. Horizontal acceleration is 0, always keep in mind. Vertical acceleration is minus g. We got trajectory path as well as got the range. These are the basic formulas of the projectile motion. So thank you for these classes. Let we learn more later on.